A very good morning, my dear students. Hope everybody is safe and sound. Really, I did not expect this kind of situation will again come into our lives. But what to do? There's no alternative for us. We must move on. One thing I can tell you to everybody, listen carefully. Face what you must face. That's it. As early as possible, we must adopt the changes according to the surroundings and go on and do our regular duties. And my responsibility is to teach, and your responsibility is to study and make your parents happy. And welcome back to the another online session of Anand Medical Academy. And now the topic is collisions. And this is the collisions topic. In some of the batches, we have finished. In some of the batches, we have started. In some of the batches, it was struck in the middle. So, introduction of the collisions is finished in every batch. And now, what I am going to do is, from the topic called collisions, we will do it. And look at here, and there are elastic collisions and inelastic collisions. So we have majorly these two types of collisions we have. On what basis this kind of classification has taken place, we have already discussed in the classes. And these elastic collisions are having one and only type, that's called perfectly elastic collisions. Whereas these inelastic collisions are having two types. One is a semi-inelastic collision. What is that? A semi-inelastic collision. So the other one is perfectly inelastic collision, my dear students. The second one is perfectly inelastic collision. And this elastic collisions, there is a law of conservation of kinetic energy is valid. Law of conservation of kinetic energy is valid here. So that means before the collision, the system will possess some kinetic energy, right? And after the collision also, the system will possess the same kind of kinetic energy and same amount of the kinetic energy. That's called law of conservation of kinetic energy is valid. And in this, law of conservation of kinetic energy is not valid in inelastic collisions. And commonly we observe the type of collisions are called inelastic collisions. So commonly observed collisions around us. So two vehicles are colliding. So the two coins in the carom boards are colliding. So those are the common type of collisions we see. Those are inelastic collisions. And we are talking about one-dimensional collision. And look at here. This is elastic and this is inelastic. And I have already told you, so there is a physical quantity called E. What is this E? And this E is a coefficient of restitution. So this is coefficient of restitution, which tells you the nature of the collision. So the value will be there for this E. So that may be 0, that may be 1, and that may lies between 0 and 1. Whatever it may be, this will have some value. So that value will tell us about the nature of the collision. If it is elastic collision, and that E value will be 1. If it is a perfectly inelastic, so that E value will be 0. If it is a semi-inelastic collision, so that E value lies between 0 and 1. Every value is very, very important here. Alright. So now one-dimensional elastic collision we will start, my dear students. One-dimensional elastic collisions. Are you ready? All right. The concept is one-dimensional elastic collisions. One-dimensional elastic collisions. And look at the situation here. So there is a body of mass m1 moving with the initial velocity u1, and there is a body of mass m2 moving with the initial velocity u2, and this is what before the collision the situation. And after the collision, what is happening andre? So there is a body of mass m1 moving with the velocity v1, and the body of mass m2 moving with the velocity v2. You carefully observe madidre. So here u1 must be greater than u2 yakandre u1 is going to collide with u2. Imagine this u2 is more. Will there be any collision takes place? No. When there is no collision takes place, there is no concept of elastic or inelastic collisions. So that is the reason, if first case alli nav yen tagobekandre u1 must be greater than u2 anta tagobeku. And the second case andre, after the collision, what is the condition we should take is, so v2 must be greater than v1. Yakandre multiple collisions concept namge beda. So multiple collisions agutte if v1 is greater. So that is why v2 greater than v2 anta navu tagolta iddivi. Okay, now coming to the point of elastic collision. E elastic collision alli, according to law of conservation of linear momentum, whatever may be the collision, law of conservation of linear momentum is valid. Law of conservation of energy is valid. Understand? But law of conservation of kinetic energy is valid only in the few collisions, and that's called elastic collisions. Okay, coming back to the point. Law of conservation of linear momentum enandre m1 u1 plus m2 u2, which is equal to m1 v1 plus m2 v2. So this is equation number 1, uncle. According to law of conservation of kinetic energy is conserved only in elastic collisions. E case alli half m1 u1 square plus half m2 u2 square. So that's what? Initial kinetic energy of the system, which is equal to, after the collision, kinetic energy of the system half m1 v1 square plus half m2 v2 square. It is equation number 2. And from equation number 1 and 2, illi nodbeku, everybody observe madlebeku illi. So from equation number 1 and 2 enagutte andre, so there is a huge derivation you get it when you divide these two equations. Equation 2 divided by equation 1 madidre, one huge derivation, and a big derivation you get it. So from that, one expression we will get, listen carefully, one expression we'll get it. And what is that expression andre? v2 minus v1 is equal to u1 minus u2 anta one expression barutte. So this is equation number 3. So careful agi ee equation nenepitkoli, and about this equation we'll speak later. We'll discuss later, maybe in the next class. So remember this, the third equation. So from equation 1 to 3, observe Mandri, from equation 1 to 3, equation 1, 2 and 3, you know what we get it? We'll get the final velocity of the bodies after the collision. Final velocity of the bodies after the collision. After the collision, final velocity is yenu anta namga barutte. What is that? Let's see. The final velocity of the first body after the collision. The final velocity of the second body after the collision. Carefully observe madri. And this V1, V2. And these expressions remembering are recollecting is also difficult at times. So that is why the easiest method to remember V1 and V2 expressions I am going to tell you, listen, because majority of the numericals you are going to solve based on this V1 and V2 only. So that is why you must remember this. So the easiest method I will tell you, ಈ equation ಅಲ್ಲಿ ಎರಡು terms ಇರುತ್ತೆ. ಇಲ್ಲಿ ಈ V2 equation also will have two terms. ಈ ಎರಡು terms ಅಲ್ಲಿ the denominators are same. Denominators are m1 plus m2. ಇಲ್ಲಿ ಹೆಂಗೆ denominators are m1 plus m2. ಇಲ್ಲಿ ಹೆಂಗೆ, so here the denominator is m1 plus m2 and here also the denominator is m1 plus m2. All right. Here it is V1, right? I am writing here it is as U1. Here it is V2. I am writing this as U2. Okay. Now, here U2 and this is U1. Here U1 and this is U2 because final velocities we are writing in terms of initial velocities, my dear students. Careful agi observe madabeku equation ge. So V2 is the final velocities we are writing in terms of initial velocities. Look at here, U2 U1, U1 U2. Here it is U1, right? And this is M1 minus M2. And here it is U2 and that is M2 minus M1. And coming back here, it's U2 and this is M2 and it is 2. And here it is U1 and it is M1, it's 2M1. So this is the expression for the final velocities of the bodies after the collision. How many times is possible for you, and that many times you need to practice. That may be 10, 15, 20, 25 times also. ಈ ತರ ನೀವು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿದ್ರೆ you will never forget this V1 V2 expressions. All right, coming back to this case, and ಈ case ಅಲ್ಲಿ for example if m1 is equal to m2 andre what will happen, let us check. If m1 is equal to m2, ಈ m1 m2 same adre what happened to the final velocities? Let us check. If m1 is equal to m2 condition alli v1 ಏನಾಗುತ್ತೆ ನೋಡ್ರಿ, 2m divided by m plus m andre that is also 2m into u2 plus ಈ m minus m ಇದು 0 ಆಗುತ್ತೆ. Understand? So this is 2m 2m cancel and u2 ಆಗುತ್ತೆ. v1 is equal to how much? u2. And the same way v2 is equal to what happens? So it's 2m u1 by 2m plus here also m minus m, that's 0 and that is u1. See how interesting this expression is. v1 is equal to u2 and v2 is equal to u1. What is happening here? Can anybody tell me what is happening here? ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ ಅಂದ್ರೆ v1 is equal to u2 ಅಂದ್ರೆ final velocity of the first body is equal to initial velocity of the second body. v2 is equal to u1. Final velocity of the second body is equal to initial velocity of the first body. Okay, clear? For example, coming back to here, idu 4 kg object ankolri and this is also 4 kg ankondre and this u1 is moving with 2 meter per second and this is moving with 3 meter per second. After collision ಏನು ಆಗ್ತಾ ಇದೆ, that's a point. After collision ಇಲ್ಲಿ 2 3 ಇದೆ ಅಲ್ವಾ, and here it will become 3 meter per second and 2 meter per second. So here 2 3 becomes 3 2. The velocities will be interchanged with the initial velocities. The velocities of the bodies after the collision are interchanged with the initial velocities of the bodies. So when one and only condition, when masses must be same, right? So this is one case. And coming back to the several other cases related to this v1 v2, here itself we will learn it. several other cases for V1 and V2. You just pause the video and you can write it, right? Whatever I have just told you, pause the video and write it. Alright, look at the situation. See the first case alva. And the second case is, imagine the second body is rest. 99% of the questions will be asked based on this. When the second body is at rest. So when the second body is at rest, your V1 and V2 expressions will become like this. So V1 expression, note, second body rest andre ee term 0 agutte. Second body rest andre ee term 0 agutte. So V1 is equal to M1 minus M2 divided by M1 plus M2 into U1. And at the same time, V2 is equal to E term 0 andre, and it is 2M1 U1 by M1 plus M2. Ee eradu formulas nan bitkobeku. So if you remember these two, and you can just substitute 0 in the place of U2. U2 0 andre enama? Second body is at rest thane. U2 0 andre second body is at rest anta meaning. Second body is at rest anta meaning. Right? Okay. So ee case alli V1 V2 expressions we have got. And let's see the first case in this part. Second body rest alide and both the bodies are having equal masses. In this situation, find V1 V2 expressions antare. So V1 expressions enama M1 is equal to M2 andre M minus M idu 0 agutte. What about V2 here? V2 is equal to 2M1 U1 by M1 plus M2 idu 2M into U1 by 2M. 2M cancel and it's U1. So what you should understand here? Observe mark. So this is the first body of mass M. Second body is also of mass M. And this body is at rest and this is moving. Okay? And this is moving. After the collision, imagine it is moving with 2 meters per second. After the collision, V1 is 0 andre first body need to come to the rest. So first body will come to the rest. And the second body must move with the initial velocity of the first body. And the second body of this mass and moves with that velocity of 2 meters per second. Observe madri. So this is body A and this is body B. And it's A and this is B. A very important case by the students. There are two bodies. One is moving with 2 meters per second, the other one is at rest. Both are having same masses. And coming to here, after the collision, this first body will come to the rest. The first body will come to the rest because final velocity of the first body is 0 bantu namge. First body will come to the rest and the second body moves with some velocity. What is that some velocity? Some velocity enandre idu. With what body initially the body started? With what velocity initially the body has started? That velocity. Understand? Coming to the next case. E case enandre second body is at rest. M1 is far greater than M2. First body is so heavy and so big. Right? And whenever it's given like this, M2 can be considered as 0. Right? M2 almost can be considered as 0. In case V1 is equal to what happens? U2 0 alva. U2 0 andre is chikka formulas aste. M2 0 anta togobekasti. Idu 0 andre M1 by M1 is 1 and it is U1. Understand? Once again I am telling you. M2 0 andre idu 0. M1 by M1 andre 1. 1 into U1 is U1. So V1 is equal to U1. And V2 is equal to here. M2 0 tane. This term will be 0. and 2m1 by m1 andre m1 cancel and you get it as 2u1. Once again I am telling you, m2 0 andre illi m1 cancel agutte and you will get v2 is equal to 2u1. And with the diagram I will represent so that you will understand 100%. With the diagram I am telling you. So m1 is the huge body, istide m1. And this is body moving with some velocity ಏನಂದ್ರೆ some 2 meter per second ಅನ್ಕೊಳ್ಳಿ. m2 ಅಂದ್ರೆ ಒಂದು ಚಿಕ್ಕ ಮಾಸ್ ಇದೆ ಇಲ್ಲಿ ನೋಡ್ರಿ. m2 is negligible when it considered to this m1. When small mass is located here, right? So here. One small mass is located here. After the collision ಏನಾಗ್ತಾ ಇದೆ? What happened to the first body? This body will move with as usual. This body, final velocity of the first body is equal to initial velocity of the first body. So andre the huge mass m1 moving with the same 2 meter per second. So the problem with this m2 only. m2 will gain some velocity. Initially it is at rest thane. And after the collision, it gains some velocity. Note, it is moving with 2 times of initial velocity of the first body. First body gains velocity is 2 meter per second. After the collision, and it is moving with a 4 meter per second. And then note, initially it's rest. Now it's moving with 4 meters per second. Alright, this is one case. Innondu case nodidre, so continuation of this. Innondu case idi nodidre, enga here a case, and the third case exactly reverse. Second body is at rest and the initial velocity of the second body is 0, and here m2 is far greater than m1 andre m1 can be almost considered as 0. Illi v1 ಏನಾಗುತ್ತೆ ನೋಡ್ರಿ, v1 m1 is considered as 0. ಈ m1 place ಅಲ್ಲಿ 0 ಹಾಕ್ರಿ. 0 minus m2 minus m2. So this is 0 plus m2 plus m2 minus m2 plus m2. m2 cancel ಆದರೆ minus ಇರುತ್ತೆ. So v1 is equal to minus u1 ಅಂತ ಇದೆ ಇಲ್ಲಿ. And here m1 0 ಅಂದ್ರೆ full, this part will be 0, numerator 0 andre complete expression will be 0, v2 is 0. And with the best example you will understand it very well, and this is the first body is very small, that's a m1, it's moving with a velocity u1. Second body is too ದೊಡ್ಡದಿದೆ, so that's m2, and which is at rest, initial velocity is at rest. ಅದೇನಂದ್ರೆ imagine this, there is a bicycle is moving towards a lorry which is stationary, and after the collision what happened? See, it's a simple common sense. There's no need of application of all these equations. Simple common sense. So there is a huge lorry is at rest, a bicycle is moving towards the lorry and collides. What happens? Will the lorry move? No, the lorry will not move. Andre final velocity of the second body must be 0. Yes, lorry will be there as it is. So after the collision, so the lorry will be at rest only. That's what the final velocity is 0, second body. And what happened to the velocity of the bicycle? Bicycle will bounce back. Understand? So this is what the bicycle mass m1, and it will bounce back with a velocity u1. With what velocity it is striking the lorry? With the same velocity it will bounce back. Idu on 5 meter per second ankondre, and with the same 5 meter per second after striking the lorry it comes back, bounces back. So idu one case. Alright, another case we'll discuss. Alright, so this is a very important part, very important case than all the other cases, my dear students. Sorry, the important case andre ide first helbek tane sir? Illa. So all these basics will help you in understanding this important case. What is this important case? Look at here. The same situation, the same situation I'm going to give you now. This is the body of mass M1 and there is a body of mass M2. Initially, this body is moving with some velocity U1 and it rested in E body. After the collision, a body of mass M1 moving with a velocity V1 and the body of mass M2 moving with a velocity V2. Observe, everyone. What is happening here? Initially, there is a kinetic energy for the first body, M1 U1 square. Imagine that's a kinetic energy. And this kinetic energy, some part is retained by this body. Half M1 V1 square. And from this value, some part is transferred to the second body. So that's what half M2 V2 square, my dear students. Carefully observe madbeku. Idu 50 joules andre and first body is possessing 50 joules and that's the 50 joules before the collision kinetic energy of the system. After the collision, that 50 joules will be transferred into the different ways. And some part of the 50 joules is retained with the first body. Initially 50 joules is having by first body. And the first body will retain some kinetic energy, that's half M1 V1 square. And some of this 50 joules is transferred to the second body. Second body initially not moving. After the collision only it is moving. Andre, from this 50 joules, some part is transferred. Okay, clear? Now, commonly the question will be asked, what is the fraction of kinetic energy retained by the first body? Understand? So this I am writing here. So this is retained by the first body and the other one is what? Transferred. So, kinetic energy retained by the first body andre this one. What is the kinetic energy of the body after the collision? By initial kinetic energy. That's called kinetic energy retained. What is this? Kinetic energy or the fraction of kinetic energy retained. This is what the commonly asked question. Fraction of kinetic energy retained. So this is kinetic energy 1. Kinetic energy 1 is this one after the collision. It is half into M into V1 square divided by kinetic energy initially half M1 U1 square. And writing this is very simple. Half into M1 into V1. After the collision, final velocity when the initial body is at, when the initially second body is at rest. So idu tane. So initially second body is at rest and final velocity of the first body is M1 minus M2 by M1 plus M2 into U1. So I am writing this V1. V1 place ali we can write this M1 minus M2 by M1 plus M2 whole square into U1 square. So divided by half into M1 U1 square. Half M1 U1 square, half M1 U1 square cancelled. And that is the formula for fraction of kinetic energy retained. Okay. Clear everyone? You just pause the video and finish it. We'll solve the numericals based on till now whatever the discussion we have made it, right? We'll do the numericals related to that. Alright, so look at the numerical given here. A body of mass 4 kg moving on a smooth horizontal surface makes an elastic collision. Elastic collision andre you should understand that V1 and V2 expressions we must write it. Okay. With another ball of mass M at rest in the line of motion, see the second body is at rest, u2 is equal to 0. Half of the equation is reduced now because v1 expression will have two terms. Adrally, one term will become 0. v2 expression will have two terms. Adrally, one term will become 0 because second body is rest anta kottidru. Alright. In the line of motion of the first. Okay. If after the collision, the first ball moves with 1/4 of its initial velocity, then mass of the second ball is how much? That's the question. Observe. We have velocity of the first body after the collision. Note, if after collision first ball moves with 1/4 of its velocity, andre it is about after the collision first body. So v1 is equal to, you have two terms with you, careful ignore. So m1 plus m2 is there, plus here also m1 plus m2. So here u1 and this is u2 and this is m1 minus m2 and it is 2m2. So as u2 is 0, this term will become 0. Here given second body is rest. Coming back to this. So v1 is how much? So v1 is after the collision first ball moves with 1/4 of its velocity before the collision. 1/4 of the velocity before the collision. Initial velocity of the first body u1 ankondre, after the collision it's moving with u1 by 4, which is equal to, and here m1 first body mass 4 kg anta kottid, minus second body mass is m, okay, it is just m, divided by 4 plus m into u1, okay. So u1 cancel here. So what to do now? 1 by 4 is equal to 4 minus m by 4 plus m. Just the cross multiplication. 4 plus m is equal to 16 minus 4m. And here, if minus 4m will be bandre, that's plus 4m agutte, total 5m. And this 16, this plus 4, it comes to the other side, that will be minus 4, 16 minus 4. Right? Okay. And here, it's a 5 ones are, and this is 5 twos, 0.54. So, the answer is mass of the second body is 2.4 kilogram. These questions will be asked. And the cases we have discussed, and the different cases we have discussed right in the elastic collisions are cases in the no question scale mode. The cases we have learned like numericals only. And coming back to this second question. There are two bodies. One is having 10 kg mass, the another one is having 10 grams mass. No confusion with the units. Okay. First body is moving with 5 meter per second and the second body is moving with 1 meter per second and they are moving in opposite directions. They are moving in opposite directions. Alright. Here. And there is an elastic collision is happening. The question is, what is the speed of the second body after the collision? Speed of the second body after the collision. Speed of the second body after the collision, you have the formula. Note, every time when I am writing the formula, with the shortcut method only I am writing the formula. Otherwise, remembering it's too difficult. It is V2 and it is U2 and it is U1. It is U2 and we'll start with M2. Okay. It is U1, we'll write M1 and it is 2 here. Fine. Now, what is the speed of the B after the collision? Simple. Speed of the second body after the collision, 1 by 1 if substitute ಮಾಡ್ತಾ ಹೋಗಬೇಕು. So V2 is equal to 2 into M1. M1 ಅಂದ್ರೆ ಎಷ್ಟು ಮೇಲೆ 10 kg into U1. U1 ಅಂದ್ರೆ 5 meter per second divided by mass of the first body, it's 10 kg plus mass of the second body, it's 10 grams. These 10 grams must be converted into kilogram because ಇದು kilogram ಅಂತ ನಾವು ತಗೊಳ್ತೀವಿ. Okay. 10 gram andre, so it is 10 by 1000. I can write it 0.01 kg, right? Plus m2 minus m1. m2 andre just now we have got 0.01 minus m1. It's a 10 divided by m1 plus m2. 10 plus 0.01. And this is important point here, my dear students. U2, this is important point. Initial velocity of the second body node, it's opposite to the previous case, opposite to the first body. Understand? So then, when we have taken this velocity as positive, and this must be negative because velocities we are talking about. Itaranu collision agata, right? So this is a -1 if the direction is different. So if you solve marta hodre, approximately you will get it. The answer is 11 meter per second. You check madri and try it and tell me whether you got it 11 meter per second or not. Alright. So this is how elastic collisions will be discussed, and the next class we will discuss about inelastic collisions. Alright. All the very best and get ready for the assignment, and shining off, and see you in the next class.